Now consider some sort of a online shopping system like a eBay or a AliExpress or whatever you can name of, or either your own system, right. Now there are usually, let us say you have a database, right. So this database you can have a 5,000 concurrent connections possible, but if your system is large, then probably you have a million users same time is kind of a searching items, especially in seasons, right, searching items, trying to buy items, add into shopping carts and do so many operations. Now your database has a limited connection, can block them, and that is one problem. Other problem is, let us say we are going to buy this water bottle, right, she come and she put into the cart, only one stock available, right, she come and she put into the cart. Now when usually girls do shopping, right, they put it and then I really need it, and then just go and see the reviews, is the color is good, this is blue color, is a blue and red doesn't match, they think lot of things. So meantime he come and try to buy this. Now what? There are two options we can do. Either system does not show this bottle to him because he is a potential buyer, right, either show to him as well, right. And if you do not show to him, then if she decide not to buy it, then seller losing potential selling, okay. And if we show to him, then one bottle, two is trying to buy. At some point we create a race condition, right. But if you go with something like a saga, what happens is you save everything, and then finally when you try to get this one, if both try to save at the same time, when you try to get this one and then one will lose the item, then you have to go for so many rollbacks, okay, so many rollbacks. So this is not easy, implementing something like the saga or a try, confirm, cancel, those type of pattern will work, but not easy. So they came up with a design pattern called CQRS, Command Query Responsibility Segregation, right, Command Query Responsibility Segregation. This is how it works. eBay came up with this idea first, right, and what it does is we have read database and the write database, okay. Let's say this is the writer, this is the reader. This can be anything, this can be elastic cache, this can be some sort of other like indexed data sources, right, to make it a fast reading availability. This can replicate to like any region or anywhere, this can do, you can do anything with this one. What we do is, when the client submit the request to write, this request is to go to a queue, right, this request go to queue, and there are queue processors which coordinate internally, right. What this queue processor does is, when the message go to the queue from here, it pick one by one and write to the database, okay, it pick one by one and write to the database. So you can scale the queue processors if you want to pass, I think. There are problems also with this one, because this queue processors doesn't know about segregating of these event itself, they treat every event equally and write to the database, but you can implement the custom logic inside that, right. So now all the reads, when this need the data coming from here, right, when you write in the data, you write in from here and then you read the data reading from here. So replication happens separately from here to here, it can be the process data, depending on how fast you need to available. When you write something, if the next second you need to available from here, then you need to go with a replication. But when you write something, within 5 minutes you need to be available, then you can have a data process way, right. This data is processed in a way that the front end needs, right. And all the reports run from here. We read from here, we write to here. The writing also, not all the requests going directly to the database. They are staying in the queue, it is a disconnected queue processor will take it and process it. If it fail, it notify back saying your transaction is failed. So, this is what we call commands. These are the commands, these are query, these are commands, these are query. Each responsibility is segregated to different layers. Okay, this is just architecture, this is a little bit deeper than that, but the like if you take the overview of the CQRS, this. But you will see now we are trying to achieve same thing, right. We are trying to maintain consistency, we are trying to handle distributed transaction failures, we are trying to do almost achieve same thing, but in a different ways. So, each one now every system CQRS does not fit to every system, right. For example, in our demand allocation problem CQRS did not fit, because CQRS has its own thing. So, we implement something on top of the CQRS, inspired by CQRS, and we implement something. So, likewise, so every design pattern does not fit to every use cases. You can make somehow it work, you can put the CQRS and to a simple inventory solution, but the question is really necessary, because implementing this type of pattern is take a lot of effort. Let us say when you create an order, you want to emit event. Okay, when you create order, you want to emit event. Which pattern we need this? Huh? Which pattern we need this? When you Saga, which option? Choreography, right? When you create the order, we need to emit event. Now this can happen. You create the order, right? Create order. So that means you save to order table. Right, you save to order table. Now, when you save to order table, this is one. Second step is you emit Kafka event. Now, this is success, this is fail. Okay? Insert to database is success. When you try to emit event, broker is not available. Now, order created, inventory service does not know that order created. See how many failures can happen, right? Huh? How many failures can happen? Sometimes we do not think even this can happen, yeah, but this is possible. You create the order, save, broker is not available. Now, someone come up with a brilliant idea, see the order broker is available before you save the table. Now, by the time you check it is available. When you save and go back, it is not there, right? Because these things can fail at any point, because these are not interconnected. This is a database, this is the message broker. Okay, within nanoseconds this can happen. Now, someone might come up with a brilliant idea saying, okay, yeah, that is possible. Let us emit the order first, or emit the event first, then save the table. Now what? Solve the problem? Huh? No? Why? Huh? Yeah. So now what's the problem? Inventory service think, okay, order created, but when you go and check the order in the table, it's not there. Okay? To solve this problem, we have something called Outbox Pattern. How many of these patterns you have heard before? Huh? Outbox Pattern. What the Outbox Pattern does is, you have another table called Outbox table. Now you have order table, right, and Outbox table. These coming from again from the mail, right? Have you seen like all government office, like the executives when they sit, there is a 2 trays on the table, enna yana, right? Incoming mails and outgoing mails, right? So in your Outlook you have an inbox, outbox. So it's something called outbox. Outbox mean the things you have to go out. So now this is you do within the same transaction. Begin transaction, insert into order table, insert into outbox table and commit transaction. Now if outbox table is fail, this also will roll back, right? So this guaranteed if you insert into the order table, it insert into the outbox table because if these are within same database transaction. Begin transaction, insert, commit, right? Now there is other third process running where what that process does is it check the outbox table. If there are undelivered events, it take it and emit into the message broker. Okay? Problem sorted. Now let us say there is a column called sent. Now it's 0. Right? Now you emit the event. Event is emitted success. Now you come back to say this is mark 1. Now this is fail. Now this is fail. Possible? You understand? This is 0, sent, sent flag is 0 for this event. Now you sent it, you send the update, this particular message, set sent 1, in that update statement failed. Now what going to happen? Huh? What going to happen? Yeah, it going to send again. Right? This message is going to send again. So in a messaging architecture, there are 2 types things called least one time guaranteed, right? Because at least it's deliver one time. That doesn't mean only one time. It can come back again. Okay? It can come back again. So consumer need to be ready if the same event coming again to understand this as a duplicate event, especially Kafka. Kafka sending the message, say Kafka can send the same message twice. When we learn the Kafka, we can understand it, right? So sometime I am the Kafka, she is a consumer, I give the message to her, right? And then she doesn't give it back to me on time. And then I am giving, so since the message didn't come, I give it to someone else. What is the pattern? When it doesn't come on time, I try someone else. Region. Right? Remember, right? So now what happens is, now she processes it. She creates this node table and everything. Now you take it and you do the same thing. And sometime later she is coming, hey, I am done. Now I say, okay, sorry, I don't know you anymore. Right? So when we learn the Kafka, we can learn it. So that means same message came twice. Okay? So in the implementation, you should take care of those type of problems. This is very much possible thing to happen. See this one, okay? So now you write to this table, some other service or your process stay there monitoring this table. If this come to this table, probably once in every minute or every 15 seconds, every 30 seconds, you go there and check this and take it, right? So now if when you go there, like in 30 seconds, you have 1 million events to send. Then there is a delays introduced because you are doing it yourself. You go and manually checking it and taking the events. To avoid this, we use a technique called CDC, right? Not the disease control, right? CDC, that means change data capture. What it means, we have something called bin log and val log. Val means right ahead logs, right? What we do is, we tell database itself, in this particular table, data change, you emit an event. Okay. So, that means when the outbox table change, no need someone go and check whether this table is changed. Table itself emit event saying I have new record. Okay. I have new record. This is called change data capture. Database itself communicate to some sort of outside event broker or a message broker saying this happens, right. So, now this is a very simple use case for this one. Let us say something like this, you are working with a solution where you have a ERP, right. Let us get a M3 or a Navision or a SAP or some sort of a ERP. You need to know these data in order to work on your microservices. Okay? But it is really bad practice to go and read this database. Why? Because you are a visitor. This ERP system is not done the capacity planning or the performance testing thinking someone else will come and read my data, because you are absent when they do that exercise, right. So, you go and read their data can create performance bottleneck on the system. So, what we can do is, so now this has a database, right, let us say MS SQL database. Listen this is very important topic, right. So, now what you do is you tell this database to emit the CDC events, change data capture events, okay, change data capture events. Now, there you can have you can use any tool for the available tool for this. There is a tool called Debezium, which is a very commonly used one. What the Debezium does is, Debezium read these events and publish to Kafka, right, publish to Kafka, read these event and publish to Kafka. So, this is called Debezium source connector, right, source connector. It take the data and publish to Kafka. And there is a other connector here, stay in this side, called sync connector, SINK sync connector. It is a Debezium also. What that does is, it take this data and it can send to anywhere. It can send to Postgres database if you want, it can send to MySQL database if you want, it can send to Oracle database, right, or it can send to even S3 buckets for a data lake kind of integrations. Right. Now, what happens is, everything happening to this side we propagate to multiple other databases. Now, it is like a CQRS, right. We take this event and send to somewhere. So, report can run on this database, microservice can run on this database, data lake cannot run these files. You understand the difference? Okay. This entire process called CDC, change data capture. So, change data capture can use for something like simple like this, where you enable one table, or you can use the change data capture for something like this, where you enable multiple tables, right. So, this is come to Kafka and the Kafka. So, now here not only for these things, let us say there is an order table here, when the order created on the ERP, if you want to do something, send an email or send it to dashboard, show in dashboard, okay, new order created or something like that, or allocate a factory or something to do that, you can listen to that from the Kafka and do it. Okay. So, we use this technique to synchronize multiple databases. We synchronize MS SQL to Postgres, and we send the Postgres to like, so you can do in any direction. For example, reporting run on SSRS, we send our Postgres data, MySQL data, MongoDB data, everything to SSRS. NoSQL, you can send to SQL databases. Right? This is a really important concept. Right? There is a YouTube channel called Krish Dinesh. So, there is a practical video how to implement the CDC, and also there is a practical video implementing a Saga pattern. Okay, practically implement the Saga pattern on I think mobile connection, right? Yeah. So getting a new connection, something, and there is a practical demo, right? You guys need to implement that one. CDC try, but it's not easy to implement because you can create two servers on your AWS account and try it. It's good if you can try, but that's not must. But that one is must. Saga. So there is other event. There's other pattern. We are not using this much because this is not much efficient, right? So what it does is, so now let's say in our previous example, you have a employee service and then you have a project service, right? Project service. Okay. So there is a pattern called not the event sourcing. I don't remember the name. I'll remember the name and tell you, right? What that pattern does is simply, so when the employee created, it emit the employee record, employee event, and this guy listen to this and this guy store a copy locally. Okay, we don't do this anymore because they do it usually because of the querying take time, the querying of HTTP taking time. So it is easy to store your copy locally, so you know what happened to the employee, right? If you get the order, you know what happened to the order. But the problem is you introducing so many duplicates records, and then it introduces so many inconsistencies. So therefore, this is not a like a popular one, but can use in certain cases, especially like IoT projects or something when you're doing. So you can do it, but I never use it, and I can't think of any use case to use it also. But there is a, if you read books on these architecture books, there is a pattern like this that is called ECS. I don't remember the name for this one. It's called ECS pattern, event carried states. Event carried state. So that means we take the event entirely to a different one, but it's okay to take a note saying there was something like that, but I don't have any use case to explain. When you're dealing with this type of event architectures, you need to understand. So now this is okay when you this in a book, this is really cool. You create an event and you publish the event, you consume the event and going on. Now sometime down the line you need to change the payload, event payload, right? So because these things, when you learn this, those are not explained. This is event driven architecture, super happy, this is really nice, out of the box, really cool thing. But the practical world is, because we are not design a system saying okay, this is how our system works, you need to run the business like this. We should do the other way around. We need to let the business to run the way the business want to run. We need to design the system to help the business. So now with the time, this requirement change, we need to do changes to these events, payloads. Okay. So now when I add a new, if I add something new to my schema, my payload, the consumers may crash. Okay, consumers may crash. So we are using a technique called Schema Evolution. What that does is, you are defining a schema for your payload. For example, I am saying, hey, my response will come name and address. Name and address. Okay. So now I am the publisher, he is the consumer and he is the consumer, they are using it. Perfectly fine. Now later on, I want to add one more field to this one. I am adding telephone number. Right? Now when I add a telephone number, I change the structure of the event. Okay? Now you are my old consumer, you will use this, since you do not know about the telephone number, you ignore it, right. She is a new consumer, she knows the telephone number comes, so she is use it. So this, when you do this change, it's a forward and backward compatible. That means the previous people also can use it, the new consumers also can use it. So therefore adding a property is always safe. But there is something called destructive modification, that means you remove a property, right. The moment you remove the property, what happens is you going to fail because you expected this property, she is not going to fail because she never knew that property was coming, because the consumer new version. So this is destructive. Okay. We use schema registries, the CDCs, especially when you do the CDC, you need a schema registry. That the YouTube channel Krish Dinesh is a really good one, and there is a schema registry example also, right. So how you can handle the schema registry and how you can run without a schema registry, right. So when you do this, schema registry tells what is the schema of this event. It can hold all the schemas and so and so. And there is a other thing called contracts to help this. There are two types of contracts. One is called producer contract, another one called consumer contract. Consumer contract. What that consumer contract does is, consumer publish a contract, the Spring has a framework called the Spring contract. They publish a contract saying, I want response like this is my expectation. Right? Now you are saying, I need name, address, telephone number, name, address, right. So now you are saying, you publish your contract, client publish their contract. Now producer, when the new version introduced, there are tools like a pack tool. This tool, what it does is, it can run on a consumer contract and see whether this modification would break someone. Because when I publish a API, there can be so many consumers, right. So when this system run for like 1 or 2 years down the line, they are doing so many things. For example, in our cluster, accidentally we open some endpoints. Now we cannot close those because there are so many people hang on this endpoint. Because we open it, they used it, right. Then we need to figure out slowly how we can decommission those. Okay. The book doesn't say those things because those are in a real world use cases. When you do something, you cannot say, okay, if I add this property, this breaks or business, so you don't sell this. You cannot tell. They say you are running a business, there is some golden opportunity. Like when the COVID came, the business went in different directions, right. The mask business was the super high business, right. So you cannot tell, okay, don't sell mask because our system doesn't support it. So you lose millions, right. So therefore that is not practical. So what we do is, we produce the contract and we run through all the consumer contracts and see who's impacting with this modification, right. So that is what we discussed yesterday. I asked, okay, when you change the payload, write a test suite to see who is breaking, because we have a system, the Apollo, we are totally relying on the incoming payload, incoming event. Then event has a structure, right. So our entire module is depending on that. So if they say, okay, we need to add a new property, we cannot say no. Why? It's a totally independent system. They should be able to work on their own way, right. But we need to safeguard our side. What we do is, what I ask them to do is, so write a contract. You guys were there? So write a contract, and then when they change the payload, we run through it and see who is getting impact. Now if it is impacting, still we cannot say them to not to change, no. So we can put intermediate layer where we take that payload and convert to the payload where we are not breaking. We add the transformation in between. That is the benefit of it. Otherwise what you need to do is, they do the modification, okay, let's see what happened, you put into the system and it work. But as an edge case, run on a month end. To run this on the CDC, we had to wait month end, no? So in the mid of the month we roll out to production, we are say happy, we go on a trip on the end of the month and then everything break. Why? Because that month end situation triggered suddenly. You couldn't reproduce. That is why this client contract is very important. If you are doing it, you need to know what you are expecting. So then you can use a pack tool, right? You can go and Google, there's a pack tool. What the pack tool does is it helps you to run the contract. This schema evolution, these are two different things. Schema evolution is used to backward and forward compatible. But the restriction is you cannot remove property. Right? So now if you want to figure it out, what's going to happen when you do that, you need to go for this contract validations. Good. See you tomorrow.